Hello again. We're going to be revising composite functions in this segment, and specifically we have a composite function which does not exist without doing some surgery on the compatibility of the range of the first function with the input, the domain of the second function. We have an example here where the second function is what I call a fussy function and cannot tolerate certain values of x for its input, and therefore we have to help it along a little bit to make this composite function exist. I will show you what to do. Okay, so we've got f of x equals x squared minus 4 and g of x is root x. Now that's a fussy function, guys. It exists on a diet of a positive and 0. Cannot stand any input of negative x, okay, because you can't have the square root of a negative number. So we've got to show that g of f of x does not exist, and secondly we've got to find a suitable restricted domain so that g of f of x does exist. Alright, very typical exam style question, so we need to really get a handle on this. So let's go. Now the range of f, that is x squared minus 4, that is minus 4, including minus 4 up to infinity, yes? The domain of g, that is the fussy function, which is the second function in the process of this little assembly line kind of concept, is from 0, including 0, up to infinity. So therefore we've got a problem, guys. We've got a definite problem here. The range of f, the first function, what's coming out of the first function, is not compatible, is not wholly contained within the input or the domain of the second function. So g of f of x does not exist as required. That's all you've got to say in an exam or a test setting, okay? Now for part B, I like to draw a picture so we can see what's going on here. Okay, we've got f is here, the first function of the process, and that is x squared minus 4. We've got g over here, that's the second one in the process, and that's root x. That's the fussy function, guys. So let's flesh this out a little bit more now and see what we've got. There is our f process. So that'll take, what'll it take, guys? It'll take anything, won't it? But it only spits out from minus 4 up to infinity, doesn't it? Yes, that's its output. Yes, get that? Alright, now let's have a look at g now. Okay, that likes to input anything from 0 to positive infinity, and it likes to output the y also from 0 up to positive infinity, yes? Okay, there they are. Now you can see quite clearly there's a problem here, you see? If we were to draw a number line, you'd see it even more clearly, and I'll do that now. There's a number line. Now, you can see that that is the range of f. Minus 4, including minus 4 up to positive infinity, yes? Okay. Now, here is the domain, or the input, of function g. It can only accept from 0, including 0, up to positive infinity. And you see, if we were just to allow the output of the first function here to go into the input of this function here, that is the minus 4 to infinity, the green line, to go into the input of this function here, which only likes what's on the red line, you can see there's a conflict, because this green line has got to be compatible with the red line, and it isn't, because the overlap is the compatibility section. You see, this bit in here is going to cause our fussy function to get very sick and to be required to be taken to mathematical intensive care. Okay, so what we're saying is that the overlapping section is where the range of f is wholly contained within the domain of g. Okay, the range of f is wholly contained within the domain of g. Yes, you're getting it. Good for you. So therefore, the range of the restricted f, okay, this one here, which doesn't upset this guy here, has to be 0, including 0, up to positive infinity. Okay, so what we've got to do now, guys, get our scalpels out and make sure that f only puts out that range. So the question then, the elephant in the room as it were, is therefore what domain do we need to restrict ourselves to for f in order that it only puts out as an output, as a range from 0 to infinity. Okay? Let's draw a graph of f and we will see very clearly what we need to do. But a picture is worth 1,000 words, as always. Now, you see the green bit that I've highlighted there? That is the bit that's on the 0 and the positive for the output, for the range of f. Okay, that's the bit that we want, remember? Because that's what we've got to input in as the domain of G, the second stage in the process of our assembly line. Okay? Now, what values of x give rise to those green coloured in values of the y? Okay, what values of x? Can you see it? Have a look. Can you see it? Well, if we take any points on that green coloured in section of the graph and draw a vertical line back to the x-axis, they are the values of x which give rise to the values of y that we want. Now you're beginning to see that the values of x we want are, what are they? Come on. Yes, that's right. They are from minus infinity to minus 2 inclusive, or from 2 inclusive up to positive infinity. That is the domain of the restricted f that we need. So therefore, the domain of g of f of x is, as we said, from minus infinity to minus 2 inclusive, or from 2 inclusive up to positive infinity. Okay, and the range of g of f of x rather is, as we said, here, from 0, including 0, up to infinity. Okay, do you get it? Now that's the process you've got to go through in your mind to work these things out. They are not straightforward. They are a little bit complicated, and you have to break them down, chunk them down into the doable bits. Okay? Yes. Fussy function. Okay. Problem. What have we got to do here to fix the problem? And then what is the ramification back here of what we've got to do here to fix the problem? Okay? Alright, now you practice that one again without me telling you, and make sure you can get it out, and we'll see you soon.